right, so this is section 5.4, logarithmic functions. Okay, so logarithmic functions are complete inverses of exponential functions when it comes to it. So just give you guys a quick definition of what it means. So I just call them log for short. So log functions. With base A, where A is strictly greater than 0 and A cannot equal 1. So it could have a fraction decimal but cannot equal 1 itself. Denoted as y equals log base A of x. That's how it looks. So this is base A, so subscript A, if you want to think of it that way, is defined by one very special conversion. So again, since these are inverses of each other, so log and exponentials, I can technically rewrite a log function, because that's the only way we can actually express it, as this. That. Okay, so that is our huge conversions from log to exponentials and vice versa. Okay, so if you notice, it's the base is going to be raised to what is equal to, and that equals the x value itself. Okay, so that is our logarithmic function equation conversion there. Okay. So this is the only way, so we cannot actually evaluate logs without calculator cells, but since you want to figure out some portions, especially graph it, we want to convert it to this portion as well. So just a quick little scenarios conversions here. Okay. Let's do a couple. So let's convert, let's say, log base A 4 equals 3. Okay. Now, the best way I can think of, or I remembered how to, what goes where is, I always write what exactly each number or letter represents, right, in our equation. So for example, A is always the base, so this is just A. Okay. X is what's being evaluated, which is the 4, and Y is what is equal to, in this case, 3. So now if we want to convert this, all we just plug in the 3 letters or 3 numbers where they're supposed to be. So now we have x equals, so 4 is equal a to the 3rd power. And that is how we're going to convert it. Okay. Let's try a couple more. Not that yet. All right, so same thing here. Okay. So a, x, and y. So a in this case is our base, which is 3. X is again is 4, and y is going to be c, right? Because that's what it equals to. Again, if I just write, according to our definition, this is going to be x, which is 4, is equal to the base, which is 3, raised to the c power. And there we go. That's our conversion. So let's try one more. All right, so same thing here, right? Find a, x, and y. So a in this case is the base, which is e, the number e. X is just x, that's itself, and y is 3. So if we use our portion, this is going to be x equals e to the 3rd power. And there we go. Right, so, well, one way is not too bad. Well, can we go the other way? So in other words, what if I give you this? Can you go backwards and give me that? Okay. So now we're just going to try going backwards. So let's say 3 to the 8th power equals m, and now we want to convert it to its logarithmic expression. Okay. So this one's a little tricky because you got to go backwards now. So we're just going to write what we have here. So in our portion, again, I just want to write what a, x, and y is. But again, now looking here, we're going to go that way. So in this case, if I rewrite this, the x value is going to be the m, a is the base, which is 3, and y is what's being raised to, or 8. And now I want to convert it back to here, so we can have y equals, so 8 equals log the base, which is 3, of m that's being evaluated. And there we go. That's our answer. So it's a little tricky going backwards and forwards. So let's try a couple more. Let's suppose we have e to the x equals 9. Okay. All right, so same template. Okay. So if we look back, right, x is what's equal to, so that's going to be 9. A is the base, which is e. And y is what's the power, in this case, is x. So now if we write using the log portion, it's going to be log of the base, so it's going to be e, of the x term, which is 9 equals x, like that. Okay. Let's do one more. All right, so a, x, and y. So y, x is what's being equal to, so that's 32. W is the base, and then 10 is the power. So now if we rewrite this, this will be log of base, which is w, of 32 equals 10. And there we go. Okay. Now if you're wondering why we care about converting forwards and backwards as well, most of the time now this is the only way we're able to solve for variables. So for example, or evaluate as well. So let's say in this case we want to evaluate each log. So we want to figure out what is log base 2 of 16. Okay. Now, unfortunately, calculator cannot do this for you because it's calculators only do base 10. So that's the reason why we actually have to do it the old-fashioned way. Okay. So because of that, the best way to deal with this is, well, what you're really looking for is what is the y value that makes this equal to in our equation. So essentially, we're always looking for y, what's being evaluated to it. And how we're going to do that is we're going to have to use a conversion to solve for the y value itself. Okay. So if I just rewrite that, it has to equal y. So that's what we're looking for, the y value. So therefore now, if I just convert this, just the way we just did it, in this case, a is going to be 2, that's our base. X is being 16, that's what's being evaluated. And y is just y, right, the letter y itself. And if we rewrite using exponentials, I now have 16 is equal to 2 to the y power. And now it makes it much easier to solve for y because I got to figure out, well, 2 to what power gives you 16? In this case, it's going to be 4. So therefore, y equals 4. So therefore, this whole thing evaluates to 4. And that's how we evaluate logs using that portion. We have to convert it to its exponential first and then solve from here. And it's usually not too bad once you do that. So let's try a couple more. Okay. So same thing, right? I just want to set it equal to y, so I know it looks like the exact same template we did before. And same thing, so a, x, and y. So if you notice, y is always going to be y because that's what we're looking for. The base is 3, and x is 1 over 9. So now if I convert this into its exponential format, this is going to be 1 over 9 is equal to 3 to the y power. Now it goes back to this last section, right? So easiest way to think about it is, well, what's another way I can write 1 over 9? That's 9 to the negative 1 power, if you like. And again, another way to write 9 is 3 squared. So I can rewrite this as 3 squared to the negative 1 power. And this becomes 3 to the negative 2 is equal to 3 to the y power. And now notice we get the exact same template we did last time. Same base, so therefore y must equal negative 2. So therefore, this whole thing evaluates to negative 2. Okay, let's try another one. Okay, kind of the same template here. Okay. So again, this is going to equal y. So my base is going to be 3. X is going to be 1 over 27, and then y is going to be y. So rewriting this gives me 1 over 27 is equal to 3 to some power. Now, if this was a little confusing for you, or you're like, oh man, this is kind of a lot of work to do with it, let's think of it this way. 3 to what power gives you 9? Hopefully you say 2, right? 3 squared gives you 9. So notice there's a 2, right? But since it's a fraction, you just pop a negative in front of that power, and that always makes it true. For instance, here, 3 to what power gives you 27? Hopefully you say 3, right? 3 times 3 times 3 should give you 27. So you know y is going to be equal to 3. Now, since it's a fraction, you make it a negative that way because you simplify the portion. And the whole reason that why that works is exactly this portion here. That's always going to be the case when it comes to it. So in this case, you can kind of skip that if you know it's going to, a little too much work and like confusing how that works. And you make this little shortcut as long as it goes in evenly itself. So in this case, that evaluates to negative 3. Okay. So let's do one more tricky one before we end this this video and do the second part. So why don't we try this one? Log base square root of 3 and you evaluate 9. And again, we want to figure out what that equals to. Call that y. All right, so same thing. Our base is radical 3. The x value is 9 and y is 9. Y is y. So therefore, we can have y equals radical 3 to the y power. Well, this is an interesting question, right? So this one, let's do the same thing we did up here, right? Because we want to solve for the y value itself. Well, again, a quick note as well. I can literally rewrite a radical in its exponential form as a to the 1/2 power. Okay, so there's just a quick little note if you guys remember from radicals. So this is in 9 is equal to 3 to the 1/2 power times y. And again, 9 can be rewritten as 3 squared. So notice this becomes y over 2. So this becomes 2 is equal to y over 2. And solving for y means multiplying both sides. Y equals 4. So notice we do the same exact template we did in the last section, right, when it comes to if you're stuck. So don't just simply guess, right? There's a mathematical format we did in the last section. We want to have the same bases. So we can rewrite this, and we know 9 is just 3 squared, and that gives us the last number and says 4. So this whole thing evaluates to 4. Okay. All right, so that's the first part of this section.